In today's lecture, we will see what is tree pruning. So, as we have discussed earlier, the technique of setting constraint is a greedy approach, right? So, in other words, we can say it as it will check for the best split instantaneously and we move forward until one of the specified stopping condition is reached. Means we are establishing or we are maintaining certain stopping condition. So one of the we are moving forward until one of the stopping condition is reached. Okay, so let's consider the following case. When you are driving a car, okay, so and we are a yellow car. So here there are two lane, that is 80 kilometer per hour and 30 kilometer per hour. So in 80 kilometer per hour all cars are there, and in 30 kilometer per hour trucks are there. Okay, now we'll see the scenario. So at this instant you are a yellow car and you have two choices. Okay, so to continue in this lane or to brake and go to the truck lane. Okay, so take a left and overtake the other two cars quickly. Keep moving in the present lane. These are the two choices you are having. Okay, so now let's analyze this choice. In the former choice, you will immediately overtake the car ahead and reach behind the truck and start moving at 30 km per hour, looking for an opportunity to move back right. So what you are doing over here, you are going to the lane of 30 km per hour and start moving on the truck lane. Okay, and you are finding the opportunity when you are going back to the car lane. Okay, so all cars originally behind you move ahead. In the meanwhile, it may happen that whatever the cars that is behind you, that will move ahead of you. This would be the optimal choice if your objective is to maximize the distance covered in next 10 seconds, right? Now, this is exactly the difference between normal decision tree and pruning. A decision tree with constraints won't see the truck ahead and adopt a greedy approach by taking a left. On the other hand, if we choose pruning, we in effect look at few steps ahead and make a choice. So what we are doing in decision tree, certain constraints are established. So we are not looking towards the steps that may happen afterwards, right? So we are directly go to the truck lane, right? But in pruning, what happen, we in effect look at a few steps ahead and make a choice. So we know pruning is better, right? So but how to implement it in decision tree? The idea is very simple. So first, make the decision tree on the large graph. So how we can apply it on the using the decision tree, that we will see. Pruning on decision tree. Okay. So obviously first we have to construct the decision tree to the large depth. Okay. Now then we start at the bottom and start moving leaves which are giving us negative return when compared to from the top. Okay, so from bottom we are searching from the bottom and comparing it with the top, means root. If negative returns came, then we will remove that. Okay. So suppose the split is giving us a gain of say minus 10, loss of 10, and then the next split on that gives us the gain of 20. A simple decision tree will stop at step 1, but in pruning, we will see that the overall gain is 10 and keep both layers. So this is the difference between decision tree and using pruning. So what we are doing in decision tree, one leaves with the gain of minus 10 and another gives us the split of 20. So we are just removing that minus 10 leaves. Okay, but what happened in the pruning, we are looking for overall gain by considering both 20 and minus 10, and we are keeping both the leaves. Now So this is all about the tree pruning. Next concept is the binary decisions. So binary decisions, how we can make the binary decision. Binary means two decisions, yes or no, likewise decision. Okay, so how we can take that type of decision, that is covered over here. So let's consider an input data set x is equals to x1 to xn. Every vector is made up of m features. So x contains various features, and every vector is made up of m features. So each of them can be a good candidate to create a node based on the tuple. So we can consider any node to create the features or to create the tuples. So according to the feature and the threshold, the structure of the tree will change. Okay, obviously. So whatever which tuple we are selecting, or which feature we are selecting, and what is the threshold of that, according to that structure of tree gets change. So that is the obvious. So here one example is given. So it's consider the class of student where all males have dark hair and all female have blonde hair. Okay, now all both subsets have samples of different sizes. Okay, so now our task is to determine composition of the class. Now we start with the following subdivision. Length is less than equals to 5 centimeter. Yes, no, and all. Okay. Now here we can directly see the block dark color will contain both males and females. So this concept is expressed using the term purity. So obviously this will give us the better choice which consists of both the classes. So the two resulting sets are now pure according to the color feature, right? And this can enough for our task. If we need further details such as hair length, other nodes must be added, right? So their impurity won't be null because we know that there are, for example, both male and female students with long hairs. So this is all about how to add the binary decision. So these are the formulas to find out the total impurity measures considering the two branches. Okay, so this is the impurity measure formula for total number of target classes, if number of target classes if we consider. So today we are going to stop over here.